Now that we have seen how to take some basic derivatives and apply also the product and the quotient rule, we can build on that and now get into the concept of the chain rule. So we will look at a specific example of this chain rule called the general power rule and then explain the chain rule. So remember that let's list the rules of derivative that we have so far. So we have the constant rule, which is that the derivative of a constant is 0. We have the power rule, which is anything that looks like x to the n. So if you take the derivative of this, it is x n to the n minus 1. Then we have the product rule, which is that if a function is two functions being multiplied, then y prime is f prime s plus f s prime. And we have the quotient rule, which is if y is equal to two functions being divided, then the quotient rule is t prime b minus t b prime divided by b squared, where t is for top and b is for bottom. And the quotient rule is if it's a constant, the derivative is 0. Okay, so let's take a look. Before we kind of go into the general power rule, let's discuss why we need the general power rule. So let's review some algebra. So given f of x is equal to 3e to the x and g of x is equal to 5x squared minus 1, find f composed with g of x. So how composition worked in algebra is this was considered the inside function and f was considered the outside function. So how this works is if you want to find f composed with g of x, you put in the inside function into f, so it becomes f of 5x squared minus 1. And how functions work is that this, whatever is in the input in the parentheses, takes the place of where x is for f. So it becomes 3e to the 5x squared minus 1. And so this is a composition. Now we can also do it backwards, which is split the functions if we're given the composition. So if we take a look, write as a composite of two simpler functions, y is equal to the ln of 3x minus 1. So what I want to do here is I want to think about what is the inside function and what is the outside function. So the inside function, g of x, would be 3x minus 1. And the outside function would be the ln of x. Because when I compose g into f, x would be replaced by 3x minus 1. So y then becomes f composed with g of x. So we're going to be thinking about this when we use the general power rule and when we use the chain rule. So the general power rule states like this. Remember, we have the regular power rule, which I also wrote on the top right-hand corner there. But if you have x to the n, the power rule is you bring down the power. Now, what if you have an inside function that's being raised to the n? Well, the way that the general power rule works is that you still do the beginning the same. You bring down the n, you subtract 1 from the top, and the key here I'm going to underline is you don't touch the inside. But then what you do is you multiply the whole thing by the derivative of the inside function. So let's do some examples and you'll see that it's really not too bad to apply. So why is this a composition? Why do we need to use the general power rule here? Well, because it's not just x to the fourth, it's 5x minus 2 to the fourth. So what we have is that we have u of x is 5x minus 2. So if I have that f of x is equal to u to the x to the fourth, then f prime of x will be, I bring down the 4, I don't touch the inside function, I subtract 1 from the top like I'm used to with the power rule, and then I multiply it by the derivative of the inside. So what is u prime of x? It's 5. So when I put all that together, it's going to give me 4, 5x minus 2 cubed times 5. And of course you can combine the 4 and the 5, which gives you 20, 5x minus 2 cubed. Now when you get good and you get comfortable, you can actually go directly here, right? You don't need to write the u, but I really like to showcase that there's an inside part. So my derivative is 20 times 5x minus 2 cubed. Okay, let's see another one. So here I have y is equal to the square root of 6x squared plus 1. So the first thing I'm going to do, so that everyone sees, I'm going to do 6x squared plus 1 to the 1/2. So my inside function is 6x squared plus 1. Now I will tell you that sometimes I get a little lazy and I just write u. I don't write u of x. So I have 6x squared plus 1, which means that u prime will be 12x. So my derivative, y prime, is going to be, I bring down the 1/2, I don't touch u, I subtract 1 from the top, multiplied by u prime. So when I put in my u, I'm going to have 1/2 times 6x squared plus 1, negative 1/2, times 12x. So now this is going to equal to, well, the first thing I notice here is that I can combine the 1/2 and the 12x. So I can cancel the 2 and make this a 6. But because I have a negative 1/2, I want to bring that to the denominator. So the whole 6x squared plus 1 to the negative 1/2 will go in the bottom, but the 6x will stay in the top. So I'm going to have 6x in the top over, and 1/2 is the square root. So it's going to be the square root of 6x squared plus 1. And here's my y prime. Let's do one more. So we have g of x is equal to 2 over x squared minus 3 to the 4th. So back when we were just using the regular power rule and we had y is equal to 1 over x to the 4th, you couldn't apply the power rule how it was currently written. What you had to do was bring the power to the top by making it a negative, and then you could use the power rule. So we're going to have to do the same thing here. And we can do that again because there's just a 2 in the top. So I'm going to let u be x squared minus 3, which means that g of x is going to be 2 over u to the 4th. And I'm going to rewrite that as 2u to the negative 4th, and that preps me to now take the derivative. So g prime of x is going to be, I bring down the negative 4, so it's going to be a negative 8u. I subtract 1 from the top, a negative 5, times u prime, because u is not just x, it's something more complex. So u prime, the derivative of x squared minus 3, is just 2x, because the derivative of 3 is going to be 0. But then I got to put everything back in, so I have negative 8 x squared minus 3 to the negative 5 times 2x. So I can combine the negative 8 and the 2x together, and because it's a negative 5, I'm going to want to bring that to the bottom, but I'm only going to bring this part to the bottom. So at the top, I'm going to have a negative 16x, and at the bottom, I'm going to have an x squared minus 3 to the 5th. And here's my g prime of x using the general power rule.